so Google Play Protect essentially relies on Play services. Right? So it's Play services there. We don't need 6, we don't need 7, we don't need 8. It's Google Play services. Right? So what's in there? This is what it's helping us do, is protect those 2 billion devices, to do 1 billion device scans per day, and to check 50 billion apps per day. I'm not sure there's any malware provider out there today that can claim that they've got the compute power or the time or the number of customers that are equivalent to this. This is why it's so powerful. Only we have got the amount of processing to grunt to even run this sort of analysis, let alone have that number of customers in the first place. Some of our servers, 20,000 dedicated processors running 24/7 just doing Android malware scanning. So what does it look like? This is a bit of a tricky slide, but there's lots of things we're doing behind the scenes. This is what you don't see. Some of it we're sort of bringing to the surface, but what you don't see is on Android, the platform itself, down the bottom left there, your bottom left as well, it's sandbox, verified boot, encryption, all the things we talked about before in terms of the Android platform, what we've done to re-architect that. It's things running on the device, like smart lock, so locking your device when you're not in a trusted area or you don't have a trusted device with you. Device manager to help you find the device if it goes missing. Safe browsing, detecting what sort of sites you're on, using some of our machine learning to work out these are sites that are bad, you shouldn't go there. Safety net, which is a process for us to scan applications and pick up sensors and information from the wild and actually tune that and make sure that we know what's happening on your device. Verify apps, which is a process we can run on install, but also is what also is running periodically to go and give us those billions of scans we're doing every day. So they're all running on the device, and we pass it through the safety net analysis engine, which is looks at all of that and looks for statistics and looks for certain events and things we've seen before, using machine learning to say, hey, this looks like bad behavior. The application analysis, this is stuff that we're doing in play. So before something goes in there and afterwards, we continue to scan this. We use a whole lot of different techniques to make sure that what goes into play is actually secure. If we didn't, we wouldn't be at 0.05%. Right? So what is the application review process like? Let's drill into one of those. So the application comes in. We run through a whole bunch of things with analysis. Dynamic, signatures, third-party reports, static analysis, heuristic and similarity analysis, sensor network. We score it automatically, and we'd work out, hey, this has just ticked a few boxes here that we think, or crossed a few check boxes if you like, say this looks like something, smells like, looks like, behaves like something we've seen before that was bad, potentially. We do a human review and we decide approved or rejected. Sometimes we won't reject it, but we'll allow it in there, but we'll give the user a warning that gets surfaced up. Hey, this type of app has been known to do phishing. Be careful. Do you really want to install it? So I'll go into each of these in a little bit more detail to sort of talk about some of the things we're doing, but static analysis is essentially looking at the code itself. We're looking purely at the app as it comes in, stripping out that APK, looking at how it was built, looking at what components were being used, and see if we can see anything in there. Is there a module in there somewhere that we're calling that's been seen before to do something bad? But then that's code, but what about how it behaves? What's the logic of the application? Is it using legitimate code, but it's doing something bad with it? So we run dynamic analysis. We run it in an Android emulator. So we have virtual machines running all the time with Android. We can put that app through its paces and say, okay, go ahead, knock yourself out, install, let's see what you do. And we then pick up bad behavior, we can actually knock that out as well. Our sensor network's picking up behavior from the apps. So the things that the app is doing, the way it's functioning, is being recorded. Right? That stuff often goes into, because the developers have Play Store console access, they can see some of this stuff coming through. We can pick up those metrics as well and see there's making a lot of API calls, this app. And it's doing something, no other app like that does this. We've seen this, and we've seen apps do this before, and they're typically bad. Right? We have a little bit closer look at that, and we can then pick up and see that the app is not behaving in a way we think it should. Similarity analysis, this is particularly using a lot of machine learning stuff where we can say, hey, with all the things we've picked up from all those other 3 points, does this mean that it looks like it's a bad application? Let's do some analysis, let's do some crunching on this and do some statistical analysis to see whether or not that is similar or not. Developer relationships. if you're a bad developer and you develop one bad app, it might have been a mistake, but if you keep doing it, we're going to know. Right? You'll find all sorts of different ways that developers use to try and hide themselves from us, and that's one of the reasons we have so many controls around Google accounts. We don't want people creating thousands and millions of Google accounts because they can use that to create a new developer account and develop the next bad app. So we do a lot of stuff behind the scenes which we don't reveal to detect who these people are and what accounts they're using and how they're creating those accounts, and we shut them down as well. And they're either shut down or we see them come up again, you look like we've seen you before, and we'll do a bit more further analysis. We do work with third-party reports, so I'm not saying that security researchers aren't required, they are. They're a good part of the ecosystem. It's worthwhile having that information out there because they do help us tidy things up. But in a lot of cases, we've got this already. But we do actually have a bug bounty essentially out there for security, where we give rewards out for people that can find security bugs that we need to patch. Yep. Yep.
What about having EMM be able to control, like, an app that Sure. Okay. So yeah, absolutely. There's a couple dynamics here. So first off, as far as like which applications should you be allowed to use? So obviously within a work profile or work managed device, the EMM and by extension the IT admin has complete control over what applications should be allowed in. In a BYOD deployment, that doesn't really make sense on the personal side. But some of the stuff that's actually possible in, for instance, work profiles on work managed device is because you have the management application on the personal side, you'll actually be able to do some level of application management, even if a personal account has been added and accessing the Play Store. You could, for instance, hide those applications or prevent them from being used. I'd say more interesting for us, at least, and something we're working to get more readily adopted. But some of the things that Gerard was mentioning, like safety net, there's a lot of tools that we offer to EMMs to be able to understand if the environment that they want to operate is actually trusted or not. So should I actually be allowing access to corporate data on this device by more than just, the heuristics that I as an application can pull, because that inherently will be somewhat more limited than what we can provide from a platform level. So for instance, safety net can report effectively remote attestation to the device and attest that the device matches the fingerprint of a device that we've certified in our Android tests, right? Our CTS tests to say, yes, this is a real device. It hasn't been tampered with. It's executing in the way that we expect. So there's a good handful of things that we do offer that go beyond just like kind of basic application management, but certainly app management within the whatever management context you have is certainly something that EMMs have at their disposal.
Is the question, Brett? Yeah. Thank you. All right, so other things we're doing, we need to obviously do the daily scans, right? And I'll show you how we're presenting that on the device as well. And we're sort of stopping apps getting installed in the first place, right, by daily scanning, removing stuff and getting it out of the environment. So here's an example. Verify apps running at install time, and basically saying to you, hey, the one I mentioned before, we're either blocking it altogether or we're going to give a warning. So that can be blocked you, or it could be a warning, right? And it doesn't just have to be Google Play. If that app signature is being picked up by us, then we know that you went and got it. It disappeared out of Play because we took it out. So you went and said, but I like that app. I've just changed devices. I will still want my poker machine app. I want to go and download it, but it's doing something bad, right? So we've taken it out for a reason, but we can still detect that. In fact, we can block it from being installed again, right? And remove it if you did manage to get it installed somehow. Periodic scans are happening, so it'll pop up now on Google Play. Will tell you with Play Protect that we've actually removed an app from you, right? So we're actually increasing the frequency of those periodic scans as well. At the moment, it's every alternative day. But if we detect some bad activity, then we can do that more often. We can target the device and say, hey, we're seeing more in this country because there's an exploit going on. We're seeing more on this type of device, and we can toggle that depending on what's happening in the ecosystem. Safe browsing is there. There's 125 different warnings. A lot of them are phishing, right? But this is using what we know about websites and what we've seen on our devices and giving you as a user the warning, this site is probably one that you don't want to visit. So I mentioned the security rewards. So we do rely on researchers, and we've actually paid out $1 million over the last 12 months to people that have actually come to us and brought us things. Doesn't necessarily mean that we ever saw an exploit occur, but it's good that we found out, and we're good that we've got that analysis, and we do work with those research partners. The sensor network, an example. This is some bad behavior of an app, right? It's just popping up. It's trying to do something, right? It's not you. It's messengers actually trying to go and send information from your device. So we can see that this is not user initiated. We can see it's bad behavior, and we can pick it up, right? So there's all sorts of telemetry we're picking up. Safety net is running on the device. It's keeping an eye on what's going on. It's tripping those sensors. Those sensors are feeding it back to us, and that's going into our engine to actually look at, hey, is this bad stuff that we've seen before? And did it actually end up with an exploit? Maybe we should actually remove that app. Statistical analysis, right? We've picked this up with certain variants of apps. There's lots of different ways that those apps were written to actually call the hummingbird, we called it, and the ghost push. We can just run the statistics and find somewhere in the code of this, what looks like a legitimate application, there's something that's bad that we've seen before. But machine learning is really helping us. This is an animated GIF here showing you as it steps through all the different types of attacks. That neural network is essentially a representation of the app and where it exists in that hierarchy of those types of bad apps or PHAs. Right? So if you run an app into the Play Store and it goes through a scan, and our research shows that it looks like one of these, then we think, well, hang on a minute, you're grouped over here in red, you're with a bunch of apps that do hostile downloading. Fair chance that if you're like one of the other 100,000 apps we've seen like that, that you might also be a bad app. Now, only we can do that. Only Google's got the power with 2 billion devices to pull enough data to be able to do a network like this with machine learning that's going to have any sort of level of accuracy. So I talked about user visible permissions. So now we're servicing more of this up to the user interface. Security settings. So in the past, you'd probably have something like your screen lock and who's your device administrator and probably not much else. Then we started bringing in the security updates so you can see the 30-day updates and which signature you're on. But now we're doing things like, look at that sort of second one there, we've got recently scanned apps. We can sort of see real time inside a Play Store that it's actually going and doing a scan, right? So this was always happening, you just didn't know, right? So actually making it more visible to you so you've got the confidence that, hey, this stuff's going on, I'm being protected here, and I can turn things off and on if I want to. I can turn on verify apps and make it always on and make it do stuff. I can periodically go off and choose it myself, go and do a scan. A bit like an antivirus tool. Find My Device is the, obviously the device manager. You don't need to do anything to turn it on, it's there. If you've got a Google account on your device, you can track it down. So this is really handy for lost and stolen devices. Works with Google Maps, so it's quite accurate. I like the story of one of my colleagues from Samsung years ago. He left his phone in a pub and he was using the device manager to go and track it down, and he managed to track it down. It's down in Victoria in the Mornington Peninsula. Went around to someone's house and he goes, what's here? But it's showing it's out the back somewhere. He walked out the back of his house. It's granny phone out the back. Called out, knocked on the door, no answer. Pushed the door, door was open. There's his phone, rings the phone, there's a phone sitting on the front table. Thank you very much. Seal it back and run off. Funny story. Enterprise, right? So we've done a lot of stuff as well for the enterprise. So Ian touched on this one, right? So the managed profiles on corporate devices. So why is that important for security? It's because it extends the reach of the work managed device to a lot more use cases, right? If you wanted the work profile, but you went work profile only before we had this work managed device with the with this work profile support, you had less control over the device. You couldn't take full control. You couldn't wipe it. You couldn't force it into zero touch. You couldn't do a lot of things, right? So this is something we've developed into O to give, I guess, corporates a lot more control over their assets, right? So it's not just a convenience thing. It's not just a user privacy thing. It's not just some admin control for IT to have more control over a device. It's about security as well, because you actually own the asset. You've got full control of the device, as well as providing the optional work profile for the end user. Zero touch provisioning we've talked about. Privacy disclosures. So we're making sure that you would have noticed this, the more and more you install apps, the more they're actually telling you this app needs permissions for certain things, right? So in fact, we had, Peter and I worked on a customer who had a developer write an app, and that app listened for an acoustic signal to pick up some stuff from a certain drink vendor machine, because it was a loyalty app. And it actually was listening to the acoustics, legitimate reason, right? It was talking to the machine to say, how many of these cans of drink have you purchased? I'll give you the 10th one for free, or whatever it is. But their app didn't actually disclose that to the end user, that it was listening, and they didn't have a specific privacy policy for that organisation. They redirected to their website, but like, where's the privacy policy that covers social apps that I've got on my device running on Android that talk about what you're listening to and what the process is that and how you're handling my privacy? It wasn't there. So we've put a lot of effort into making sure the developers follow these guidelines, and also then serving that to you as a user to make a choice. Is this app allowed to actually do this? Maybe it's not. Maybe you didn't know the app needed that. Maybe the app won't work without it. Maybe you don't want that app anymore. We've gone through the streamlined profile setup, with all the different ways of provisioning a device. Let's get through that one. Verify apps enforcement, so we can actually turn on the verify of apps. So we can actually say for a work profile device, we force verify apps on. So you don't have to worry about the user toggling that on. It's always on if you push that for the work profile. Work challenge, particularly in that sort of BYO scenario or innate when we do the managed profiles, you might want to relax the personal side of security and just say, look, I don't need a screen lock. We don't need screen locks anymore with things like encryption being built out of the box. We don't need the screen lock to be part of the encryption key. So you can have no screen lock. If you just want to turn the device on, go straight to Facebook or straight to a phone call, you can. The IT administrator can say, but for you to launch SAP or your email or your finance application, you need a password that's different to the screen lock, right? Or more complex than the screen lock. Screen lock might be swipe with a pattern. You might say, I want 6-digit alphanumeric for these apps, because you'd put the phone down, you don't want someone just to pick it up and guess your 4-digit PIN code, which was on the driver's license they also stole from you. Improved data at rest protection. So we've got timeouts for this, so that we can know that we can actually go and ask for a better unlock method. So the longer you leave the device, you might need to go back to a stronger version. Certainly notice after reboot, you've got to, usually if you've got fingerprint, you can't use fingerprint to unlock the first time, but we can also do stuff around, the device hasn't been rebooted, but fingerprint's no longer suitable, because it's after a certain amount of time, and we can actually tell you, well, actually, you've left the phone for a long time, may have been left in a public place, someone else has picked it up, we want you to have a stronger password on it. Advanced forensics and encryption. So we went a lot in here around essentially posture assessment of the device, right? More analysis that we can do, particularly on company-owned devices. We can stop people rolling back with the verified boot rollback process. We can reset passwords on devices that are work managed. We're doing lots of network logging, right? This is all stuff that's applying to these work managed devices, right? So really sort of strong things we can do. The safety attestation API is an example of Android Pay calling that. We've got one of the banks in Singapore calls this as well for their internet banking application. They won't install their app on an untrusted device. All right? So we're not relying on just Google to scan their app in the Play Store and make sure its app's okay. Not just relying on the native protections, we're actually saying the app will check you and make sure your device is secure, and if it's being compromised, it won't install. Do you know who the largest user of that safety net API is? Can anyone guess what this is? Pokemon, right? So if you were able to trick the device and compromise it and tell it you were where all the Pokemons were, then the business model would go out the window. So Pokemon are actually using the safety net API for that reason, to make sure the device is running in a secure and uncompromised fashion. So as a recap there on some of these, right? Application isolation. We talked about some of this before around the platform itself. Android being more secure from Android KitKat onwards. The sandbox, the native SE Linux sort of permissions, the trust zone, right? The device integrity. So we're stopping people from being able to take the hardware root of trust. We've got verified boot. We've got encryption turned on. We've got all these security services running there. We've got smart lock to lock the device if you're outside your trusted Wi-Fi where you don't have your smartwatch on. There's lots of things around exploit mitigation, and then there's a whole lot of management stuff we've built in around VPNs and PIN codes and authentication requirements, certificates, handling this sort of stuff that's in the platform. The patch management, a couple of stats on that. We've worked with the ecosystem to take it from 6 to 9 weeks for the OEM to start working on, for the time to deliver an update after the OEM work was done. So we pass it on to the Samsungs and whoever else. We've got that down to less than 1 week for it then to be passed on past the OEM to the carrier channel. Right? So we're doing our bit to make sure that the ecosystem gets this quickly. At the moment, there's 5 OEMs involved in that program formally, plus Pixel. 29 device models by 351 carriers. There's a lot of devices around the world that are running this. Not to say that there aren't others that are already doing it as well. They're not just necessarily formally in the program, but we're encouraging all of our ecosystem vendors to adopt this because it's something our customers are asking for, particularly in enterprise. So if you were going to choose an enterprise device, you'd be sort of, for a start, zeroing in here, and then if they're not on this list, asking that OEM, what's your commitment level to this? Right? Doctor, can you guarantee that we're going to get these updates? So the progress has gone from 20% of those top 5 OEM flagship companies to 50% of them actually doing the updates. On Pixel, it's 90%, obviously, because it's ours, so it's a little bit easier for us to get it out there. But our goal is to have essentially 100% across everyone. So has anyone got any questions on that? Because I mean, I don't want to go too deep on some of this sort of stuff, but I think that's enough to sort of give you some really cold hard statistics about the reality of the threat out there, along with all the things that we're doing in the platform.
The app-based passcode, can you differentiate between user groups? So if you had, say, branch customers, branch staff using a certain app versus head office using the same app, can I get them to have different passcode requirements?
So that's probably, I mean, you can jump in if I'm wrong, but I'd say that's probably more of an MDM configuration thing to say, where's your passcode policy applied to, and is it applied to the whole group of the organization, or is it applied down at different all groups?
Yep. So fairly standard. It's just like any other policy that you would apply. So it's fairly standard for EMMs to have the ability to split off policies according to different groupings. And that's certainly something that all of our major EMMs that we work with support. Other question?
I just wanted to know, is there a service available or something similar, say there was an outbreak of something affected several important users in your organization? Is there something you can reach out to Google to have a look at to help in that sense?
Look, certainly come to me in any of those sort of situations. I mean, I think across the board from a support point of view, the way I see it is you've got an ecosystem, right? And anywhere in that ecosystem could be where I guess the root cause of that is. The hardware vendor, us as the platform provider, the MDM, the app vendor, the way that the device was deployed and the way it was managed and some of the things you did or didn't do to deploy it. So I think not just related to security, but related to going forward today, if you've got a problem, I would always say, go back to, firstly, who you bought the device from, they are then going to have a partnership with the OEM. That OEM is going to have a partnership with us. If it's an MDM question, that MDM also has a partnership with us. So Ian and Eugene and Kevin and Frank and their team all work together with the MDM vendors. So if it becomes an MDM issue, it goes back through that channel. But you can certainly come to us and say, hey, I've just logged a ticket with Telstra and with AirWatch and with Samsung, and I'm having this issue, and you want some visibility of it. We'll ask for all the usual stuff like bug reports and, can you reproduce it and what sort of behavior caused this to occur, and we'll go through a diagnosis process. So certainly happy to work with you on helping you triage that and work out where the fault might be, and also then where we're necessary escalating inside those organisations where, because us as a platform provider have got partnerships with all those providers, right? So whether it's Telstra or whether it's VMware or whether it's Mobiline, etc. So does that answer probably part of the question, Rod?
I'd also add that we're pretty forthcoming about what goes into every security patch. So you can actually look and see every single thing that was added into that security patch and why. And there's attribution as well, so you can see that where the report came from and why is it important, why are we taking it on for that version. So if that's the kind of granularity and data that you're looking to evaluate, it's all publicly available.
Heard quite a few questions on the Q&A. You happy to take a few of those now?
Yep.
This one from Andrew. Google Play protects. One, any plans to feed application data /warnings/actions back to EMM?
Just to reiterate, the kind of the application for just generic applications, that's not really something that we provide to EMMs, and they don't really need to consume that data. If the applications that they can manage and distribute to a work profile or work managed device reside within Play. So all of the features of Google Play Protect and all of that richness that Gerard just described, they benefit from for free, right? So they can't distribute an application to you that didn't pass review and is not available publicly. And then there's kind of the second class of things like safety net that allow your EMM vendor to ensure that they're operating in a safe environment above and beyond what they might have already done in a previous life.
Second part of that question, any scoring/warnings supplied to EMM when adding applications for deployment or after the fact, effectively a form of threat management?
Yeah, so right now it's kind of it's a Boolean kind of option, right? Either it's good to go or it's not. It's certainly something we're looking at to kind of help make recommendations through Play. So all of that great machine learning that can tell you if an application is potentially harmful or not could also be used to make recommendations about the kind of applications you might want to deploy in an enterprise context, right? Like you deploy this app, maybe you also want to deploy this app and things like that. So we're certainly looking at ways to leverage that kind of technology, both across just like usability, but also from like a threat assessment level. But generically, you should be, it's designed so that you deploy with confidence regardless of the application you choose using your EMM, as long as it goes through Google Play.
Question from Tom. Can the work challenge in work profiles be configured to use users' existing credentials as the unlock password?
Yes, okay. I'm just going to come stand up here.
Yeah. So you can, that's one of the options you can say, and you can see it on your device yourself. If you have a look, if you've got a 7 device or later, if you go into the security settings, you can tell it, do you want to use a different passcode for work apps than personal? This is on the work profile mode. And if it's different, then what are they? Right, so you can then go and define that. So that's an API that the EMMs have got.
Yep, and the user can always merge them. So if you're not a fan of entering a passcode twice because you always launch into your work Gmail, and so you don't want to enter 2 passcodes every time you unlock your device, you can take the more restrictive properties of both and set it as your device passcode so that you unlock both profiles in a single go. But it's kind of up to the policy that's been applied.
With the extensive Google security process, do you see any value in third-party app reputation services?
Sort of kind of answer that. I mean, we're not saying you don't need them, but I would query the return on investment for the number of times that they're going to give you a result versus what we can already tell you and what we're already doing on the platform. I mean, if we can claim 0.05% infection rate across 2 billion devices, how much money would you pay for someone else to give you some additional protection?
Yeah, I mean, I would use the same kind of logic as was applied when we were talking about Samsung and Knox, right? Everything that you've heard today is stuff that we've added into the platform so that you can deploy the platform with confidence. If there are additional things that you think you're not quite getting, or niche features, or things that are very specific to your deployment needs, then we absolutely encourage you to find the right tools that you need. But we want to make sure that Android generically is in a good place. And we think Google Play Protect, all of the stuff we built into the framework, brings up the bar to a very good place that anyone could deploy with confidence for most use cases.
Does the Find My Device persist, and are you still able to locate a device if the device has been factory reset and the user's Google account has been removed, but it still has connectivity?
Is that because you don't know?
Well, okay. So factory reset protection would kick in at that point. So if the device has been factory reset and you already had the Google account on it, then assuming that the device wasn't unlocked and lying on the table and somebody snatched it and immediately did the things that they needed to do, the device would be locked. And so the only way to factory reset that would be what we call an untrusted reset. And an untrusted reset kicks in the factory reset protection workflow, which means that the very first thing that happens when the device boots up is it asks for your Google account credentials. So you cannot use that device until that device is unlocked using the Google account credentials.
But you wouldn't be able to locate it.
No, because I don't think it locates it at that point because the device is not even set up yet.
Yeah, so it won't even be on Wi-Fi.
Okay.
It's a brick.
Yeah,
Yep.
How will instant apps work with managed devices? Can this be blocked?
Yes. So kind of as for those that don't know instant apps, it's a very cool play feature where you can navigate to a URL in your browser and start legitimately a native application experience using native Android APIs, and the application can silently install itself as you're navigating the app. So it's very cool for consumer use cases. It's terribly terrifying for enterprise use cases, and most IT admins would be very scared about the premise of somebody installing Facebook just because you navigated to facebook.com using a work browser. So disabled by default to start, and we're evaluating ways to add it back in. We think there's some pretty cool use cases like provisioning. Maybe you go to a URL and then it does the provisioning for you instead of having to install an application. But anyways.
A question from Georgia. Do you offer services such as app security review for in-house app-developed enterprise apps, either developed via private Google Play Store or MDM App Store?
So it's a good question. And I think really the answer to that, and this is what we encourage everyone, is, and in fact the session that didn't actually come up in the session that we had with Adrian, with some of our customer groups the other week, by virtue of putting the app in the Play Store, you're getting that scan for free. Right? So it's not going to go in the first place unless it met all of our requirements. We don't always do all of the scans straight away because we wait for it to be downloaded, installed, and then it becomes more interesting to us when we see it on a wider range of devices. So one of the things that Adrian took the feedback is there maybe a tool set we could provide? We could, separate to publishing something to the Play Store, put it somewhere and run the same app analysis over it and call more of those APIs. There's something under consideration to do that, but essentially, if you're going to put stuff in play in the first place, it's not going to get in there if it's not suitable, right? So definitely that should be your private application store. We don't necessarily see the value of continuing with other alternative app stores once you're on Android Enterprise.
Yeah, and once you're in Android Enterprise, just to you do get all of that goodness for free. So you can privately publish applications just to your users, and they are hosted within Google Play, and so instantly benefit from all of the checks, all of the scans. Like it actually sometimes it causes some issues because internal developers aren't quite used to that level of rigor. So maybe you upload an app and you're using a very old OpenSSL library, and we won't actually let you deploy that application because it could be harmful to your users. That's a bad thing, and it shouldn't be on a device. And so you actually have to change that before you can publish that and deploy it using your EMM.
Yeah, so in our customer panel, James, if it's all right, I might ask you that question. James from Spotless, and certainly went through that. And another customer that we deal with in Queensland in the cement business, they also have the same thing. And some really great feedback from saying, hey, it was a bit of a pain to go through all the steps to actually click all the different things I need to do to get into the Play Store. But tell you what, it's helping us keep our developers honest, right? So it's really helpful process.
We've about 10 minutes left in the session. Do you have more slides? Should we?
There's no more slides.
Okay.
Happy to take more questions, or we can break early
I've got
for
more
a
questions.
comfort break.
Oh, sorry. There are more questions. I'll take a couple more and then maybe do that. So can I see when a BYOD or CYOD device has attempted to download a non-Play Store app?
So presumably that's using the personal side of the device, right? So the user navigated to some website on the personal Chrome, grabbed an APK and is attempting to install it. So today, you're not in a position to prevent users from making that install. It's something that we are looking to add very quickly to be able to, so it's one of the few sort of management capabilities that would go from the work profile and actually infringe on the capabilities in the personal profile. As a general rule, that's not something we like to do, but there are select cases where we think it's important, and this is one of them. So it's not available today, but expect to see something around that soon.
Question here. Google Play is only available from Lollipop. The new Android and enterprise enhancements, including splitting personal and enterprise, I think is only available from KitKat. Does this determine the minimum version of Android for BYOD strategies?
Absolutely. So just to clarify that, so on KitKat's when we moved to the new version of, I guess, a security enhanced version of Android, so with more policies in there, but with not a lot of them turned on, it wasn't in what we call enforcing mode. From Lollipop, we went to enforcing mode, and I guess with each one that we increased more and more of those SE Linux policies to provide stronger protection, and then put a lot more sort of requirements, particularly on from 6 when it came into hardware like encryption. But to run the work profile, the minimum support, there were different flavors of Lollipop, but typically a 5.11 device. And a good example is the Panasonic that's over there, the FZN1 is a 5.11 device, so it was the first version of Lollipop that most manufacturers provided work profile support for. From 6, we made it mandatory. So work profile support became mandatory from 6. So that's why typically when people come to us and say, look, I'm going to start rolling this out, I would say I'll set 6 as a minimum because we know that there's not going to be any issues with people bringing along Lollipop devices that don't have support. It being the first version as well with Lollipop, there are a couple of little niggles in terms of the user experience, contacts handling and a couple other things that we fixed with 6. So it'll come down to what you're prepared to tolerate, what your requirements are as to whether you go as low as 5.11. I did 0.01 devices with Coates Hire coming this afternoon, but they end up taking them out of their environment. So it depends on the panel this afternoon as well. So they sort of stepped it up and said, we're going to go 6 minimum because there were a lot more features they wanted in 6 that made it more stable for them. So yeah, it does, when you're setting a BYO policy or what I would call a CYO policy or choose your own Android, I would certainly recommend best practice would be to start with 6.
Maybe one more question.
Yes.
Or unless there's has anyone got a live question? Okay, I'll take the last one.
Yeah, so sorry.
Oh, yeah, sorry. If we use MDM to host our apps rather than Play Store, would this be defined as side-loaded? And therefore the risks of malware, etc., would be representative of MDM hosted apps?
I'll answer this one and Ian come over the top. So no, because the MDM as a device administrator, if we're talking about an Android enterprise enrollment, right, it's the device admin. So it can do that, it can use private application store. But then you're maintaining apps in 2 locations. So I would query why you would want to do that. You can have a private channel in play. The apps are hosted pretty much the same way, but you get all of our security services there. The benefits you have with us is, from an end user perspective, it installs the same way. It's available in the same locations, in the same play panel you'll see in your Play Store when you're looking at the 3 tiers of apps like that you're going to go through. So it's, I guess, from a user experience point of view and management point of view, it's probably simpler just to do public and private at the same location, but you can still do apps out of the
right.
AMM.
But that's specifically using our tools, right?
Yes.
Yeah. So I mean, just more granular than that. If your application distribution is not going through Play, it has to generically be bucketed into what we call side loading or untrusted sources. There is Play and there is everything else. So a lot of what Gerard's talking about are different ways of leveraging Play to install applications. Like for instance, maybe you have an application that serves applications through Play, but shows the front end in a different web UI, right? Some of our large partners like MobileIron and AirWatch previously had their own Play UI, but they would still serve applications through Play. So if your application is not going through Play, it is coming from an untrusted source. It means that you're ticking that box in security, and it means the rate of potentially harmful apps, as you saw in that graph, goes up by a magnitude of 10. It's as simple as that. Keep untrusted sources unticked. Do not distribute apps outside of the Play Store to your users. It's in the data. We have 8-10 years of data to demonstrate that this is the case, and that Android is much, much more secure when you distribute applications and receive applications only through the Play Store. I think
if I can add something to that. So Ian is absolutely 100% right. And the unknown sources, conversation is something you're going to see a lot more from us, from Android and from Google in general. So it's important to keep that in mind. Like the visibility on this kind of stuff is going to go up a lot higher. We really think that unknown sources is probably one of the biggest risks when you think about deploying Android in enterprise. So
are you considering removing that completely? I mean, if you're pushing everyone to the Play Store, the host.
That's a good question. Stephen, are you waving me off? Okay. So currently we're not thinking about doing that. There are a number of other sources of applications on the consumer side that utilize unknown sources, right? Other web stores or other app stores, et cetera, et cetera. So our approach to this is to ensure that enterprises are moving to the Android Enterprise framework and set of APIs where we can actually control that a lot more closely.
I have a question. Do you upload the private apps to the private Google Play, will it scale better? Will they deploy quicker?
Yes, absolutely. So just very briefly, we have a little bit of time. We have two methods for distributing private applications with Android Enterprise. The first is where you host the application with Google. It is far and away the recommended deployment model, and I'll tell you why in just a sec. The second one is a self-hosted model, right? Where you give us basically enough metadata about the application such that we can broker the transaction between whatever server is hosting the APK and the device. So the install still goes through Play. It's still trusted, right? And it's very important for us. It's not an untrusted source. It's not an untrusted install. But then we don't store the APK data, right? And that's if there's application data. If you've built your APK in such a way, and we would actually also never recommend doing this, that the APK itself has corporate sensitive data in it, right? It's not a best practice at all. But if you're in that position and you really don't want Google to have your APK, there is a method. Now, benefits of the Google hosted method are numerous, including all of the scanning and protections that you just saw, right? If we don't have the APK, we can't really do that in the same way necessarily. But furthermore, you also get advantage of our massively scaled distribution mechanisms. So I'm willing to bet that we're better at serving applications than anyone who wants to set up that APK on their one server. In fact, it can only be one server. It can only be one location. So yes, you can take advantage. Effectively, you are leveraging Play's infrastructure to deliver your private application to your users. And that should be a really exciting thing. We certainly think it is.
Speed and does the EMM then responsible for controlling the level of update speed and being able to stage and stuff like that? Or is it once you upload it, it just...
Well, so it's even more. I mean, you do because you are your own developer. So as soon as you are ready to push an update, and you can, by the way, you can use all of the developer tools that Google Play offers to every developer. So you can have alpha and beta channels for testing that application before you push it to production. You can have multiple APKs that serve to different device types or different form factors if you need to do that level of customization. So once you push it to production, then yes, Play is responsible for updating on all your devices. Your EMM can also send a silent update request if they like, but Play is pretty good at auto-updating and making sure that it does it at a time that is not going to interrupt the user's workflow nor consume a lot of device battery or data.
It's over there, man.
No, completely free.
Well, we got one huge charge, $25 once.
Oh, right, yeah.
There's a $25.
Okay, so not
you
completely.
need to buy a developer account if you want to upload apps to the Play Store. So one of your developers will pay $25 once off. It's really there, not so much because we want to make revenue from it, but it's having a billing mechanism in there. It gives us another metric to try and stop some of the fraudsters from going in there and creating thousands and thousands, because it's going to cost them $25 every time, right? They might use the same PayPal account or Western Union or whatever else, so we can track that. So it is a cost. We've also released a private app publishing guide, which is a fantastic thing that our product manager wrote up a few weeks back, and it's gone public. So in the deck that we send out to everyone else, I'll include that. It's good sort of 10 pages or so of how to create a developer account, who should have access to it, how many you should have, how do you delegate to external parties, how do you upload, what are the options for upload, where do you host, all the benefits, pros and cons of each approach. So everything you need to know about that is in that guide, which is really awesome.